Let us start third law of motion, the last law and third law of motion. This is very important law in your daily life. This is also very important law in your future life. Your daily routine depends on Newton laws. And from this, third law is very important. If you ask your daddy or your mom about physics, that which law out of the total academic career of your mom or dad, which law you remembered? Okay, ask them. They said 50 to 80% parents said about this third law of motion. Third law of motion is very simple. Action and reaction are always equal in magnitude and opposite in direction. We try to understand with the help of some daily examples, daily life examples. Action and reaction. See, action and reaction are always equal in magnitude and opposite in direction. Action and reaction. Action and after that opposite reaction. What do you mean by action? Action means an effect which you apply for the first time. Because of this effect, some reaction means opposite effect occurs. This action and reaction are always equal in magnitude. Magnitude means value, measurement. Their measurements are equal and direction is opposite to each other. As for example, if you throw a ball on the wall with certain force, the wall gives you the ball with same force in opposite direction. This is Newton's third law of motion. Very simple. If you can see that when bullet is fired from the rifle, right? A bullet is fired with certain momentum. The same force is applied on backside on your shoulder. And that's why the back of the rifle is made up of heavy metal. Reason. Back of the rifle is made up of heavy metal. Why? Because when, according to Newton's third law of motion, when bullet is fired from the rifle, then it moves in upward front direction, forward direction, right? And according to third law of motion, in opposite direction means in the backward direction, the same amount of momentum exert. When it exert on your shoulder, then it hurts the shoulder. Okay? So to overcome this, if the back of the rifle is made up of heavy metal, then it absorbs this shock and your shoulder remains safe. While swimming, do you know swimming? Out of the many, I think so in today's era, generally every children should know swimming and they know swimming, that I know. Okay, so when a person is swimming, then he or she try to move his hand, try to move the water with the help of his hand, try to move back in backward direction. Means water moves in backward direction and the body moves in upward direction. This is because Newton's third law of motion. Suppose a boat is at seashore. Okay? If you are in the boat and you try to jump out from the boat, then you come in the forward direction and boat moves in the water, means in backward direction. This is Newton's third law of motion. Okay, so with the help of the daily examples, many examples are there. If you as for example, bow and arrow. Okay, if you stretch the string of the bow, then arrow moves in forward direction, it covers more distance, right? If you want to jump long, means long jump, then you have to run from far away. This is Newton's third law of motion. Very best example, the best example of Newton's third law of motion is about rocket. When rocket is at launching pad and ignition starts, means combustion starts simultaneously in all the machine, right? So the hot gases comes out from the nozzle with certain momentum, and the same momentum exert in the opposite direction, and because of this the total rocket moves up, lift up in the air, means force exerted on the earth and the rocket moves upward in the air. This is the best example of Newton's third law of motion. And very simple example of Newton's third law of motion is what? When you are walking. When you walk, you try to exert the force on the floor, and the same force is given by the floor, and so that you can walk. So while walking, think about that. This is Newton's third law of motion. Means all the first law, second law and third law are related with your life. Okay? Newton's third law of motion is very simple. Action and reaction are always equal and opposite. Equal in magnitude, opposite in direction. There is no formula, there is no derivation. You have to learn it and you have to give example of it. Okay? Now after that, last topic of your lesson about momentum. You know that you have learnt about Newton's second law of motion. Newton's second law of motion is what? Second law of motion. Newton's second law of motion is what? F equals to ma. Right? You know that acceleration, what? Acceleration A equal to what? Change in velocity per unit time, v minus u upon t. So F equal to m, place the value v minus u upon t. F equal to, multiply this, mv minus mu upon t. Is it okay? mv means what? Mass into velocity. V stands for final velocity and u stands for initial velocity. So final momentum and initial momentum, I can write Tf minus Pi upon T. So again, this is the another corner question, not given in your textbook, but it will ask F equal to final momentum minus initial momentum upon time. So from this you can derive the definition of force again. I told you that force is what? External effect with which position of the body can be changed. According to second law of motion, what is called force? Product of mass and acceleration is called force. And now in the language of momentum, you can say that Pf minus Pi is also denoted as delta P. Delta P means change in momentum. So here change in momentum per unit time is also called force. Change in momentum per unit time is called force. Okay? Suppose in the exam definition asks that write or define force, then you have to write only what? Force is an external effect with which position of the object can be changed. And suppose the question is asked about momentum, that define force in terms of momentum. Define force in terms of momentum, then you have to write this. Change in momentum per unit time is called force. You can write formula also. If you write formula, then it increase your impression that this person or this student understand the laws very well. So you must have to write this formula, both. Okay? So which increase your impression also. Now the last topic of your lesson is conservation of momentum or law of conservation of momentum. Law of conservation of momentum. See, this law we explain and try to understand with the help of an example. In exam also, if this question will ask, then you have to write in the same style. Okay, the textbook style is slightly different and my style is also slightly different, but you can understand this style very easily. See, suppose there is a marble, call it A, and another marble, call it B. This marble has a mass m1 and this marble has mass m2. Initial velocity of this marble is u1, initial velocity of marble B is u2. Okay? It moves with certain velocity u1, here also it moves with certain velocity u2. Now both the marble moves towards each other in this direction. See. So you can say that after some time they will collide with each other. Okay. So the figure is just like this. Marble A, marble B having mass m1, mass m2. When they collide with each other, then according to Newton's third law of motion, action means collision, and after that reaction, they move away from each other. Suppose this marble moves in this direction and this marble after collision moves in this direction. After collision, remember one thing, that mass of the object remains same. Mass remains same, but remember mass never change. Not only on the earth, even in universe also mass remains as it is. Okay? So mass remains as it is here, mass does not change, but the velocity changes. Because of this strike, velocity changes. Suppose the final velocity is v1 here and final velocity of the marble B is v2. Is it okay, the illustration? Now here, according to Newton's third law of motion, we can say that marble A exerts the force on marble B, at the same time marble B exerts the force on marble A. If marble A exerts the force, we try that force FA to B, means marble A exerts the force on marble B. At the same time, marble B exerts the force on marble A, so we write FBA. Is it okay? Now, you know that action and reaction are equal, means they are equal, means forces are equal to each other, but opposite in direction. The direction is opposite to each other. So we can say that according to Newton's third law of motion, according to Newton's third law of motion, the forces produced FAB is equals to FBA, but they are opposite to each other, so you should write minus FBA. Forces are same, means equal to sign is there, but they are opposite to each other, means one is positive, another is negative. Now, before collision, see, before collision, and here after collision. See, marble before collision, momentum, initial momentum of the marble, initial momentum, marble A, it is M1 U1, marble B, it is M2 U2. Final momentum, for marble A it is M1 V1 and marble B it is M2 V2. Okay? See. Now according to Newton's third law of motion, you can say that FAB equal to minus FBA. Force is what? Change in momentum per unit time. So I can write delta P upon T. Here minus delta P upon T. Change in momentum per unit time. Both the side in the denominator it is same, so cancel. Delta P is not cancelled because delta P is what? Change in momentum. Momentum of marble A and momentum of marble B are different, and that's why it is not cancelled. Now change in momentum is what? PF minus PI equal to minus PF minus PI. This is for marble A, this is for marble A, this is for marble B. Final momentum of marble A, M1 V1 minus initial momentum is M1 U1 minus final momentum of marble B is M2 V2 minus initial momentum of marble B is M2 U2. Place this value. Open the bracket. M1 V1 minus M1 U1 equal to, open this bracket. Minus is there, so sign changes. Minus M2 V2 minus minus plus M2 U2. M1 V1 minus M2 V2 moves in this direction, so it will be plus M2 V2, and minus M1 U1 moves in another side, it will be plus M1 U1 plus M2 U2. So from this you can say what? Final momentum, sum of the final momentum of marble A should be equal to sum of the final momentum, initial and final momentum are equal. Though forces are applied, though velocity changes, initial velocity of marble A and final velocity of marble A different. Initial velocity of marble B and final velocity of marble B is also different. Though velocity changes, mass remains same, but sum of the momentum always remains same. Okay? So before collision, sum of the momentum of two objects, and after collision, sum of the momentum of two objects always remains same. This is called law of conservation of momentum. Though velocity changes, but sum of the momentum always remains same. Try to understand it again and again by repeating this. After that, some examples are there. In-text example is for you because answer is already given, whereas exercise example is for me that I will explain you. Remember, in this lesson you have learned Newton's first law, second law and third law, and in your daily life also try to understand this effect of different laws. Okay? If you wake up and you walk towards the bathroom, if you walk, think that this is Newton's third law of motion. If you lift the toothbrush, think that this is Newton's second law of motion. Steady object remains in steady state until you apply any unbalanced force. This is the Newton's first law of motion. So every time, here and there, from your morning to the night, everywhere there is Newton's laws. So that's it for this chapter. In the next lecture we will discuss about numericals. Okay?